Hello, hoping you are fine. Welcome to this video. We are going to continue to look at oxygen, and today we want to look at the reactions of oxygen with metals. Reaction of oxygen with metals. So, oxygen reacts with metals to form what we call metal oxides. So, a metal plus oxygen will form a metal or metallic oxide. Now, these metallic oxides in most cases are basic in nature. So that means that if you dissolve the metallic oxide, which is soluble in water, the solution that is formed will turn red litmus paper blue, as we shall try. And then some of the metallic oxides are amphoteric in nature. That means they have acidic characters and basic characters. So today we want to look at how these metals react with oxygen. And basically we know that air contains oxygen. Therefore we are going to burn these metals in open air so that it reacts with oxygen. So let's go to the practical bit. So I have there metals. The first one there is magnesium. The next one is calcium. The other one is copper. And the last one is zinc. So, we are going to start by burning magnesium in air. Remember, it will react with oxygen. So, I'm going to put on the Bunsen burner. Light the Bunsen burner. Good. Then, magnesium is here. This is called magnesium ribbon. Can you see the color? Good. Now, I want you to note the color of the flame with which magnesium burns and the color of the product. So this is magnesium. I'm going to hold it with a pair of tongs and I will burn it there. You see that? Wow, that was beautiful. Now, magnesium oxide that is formed there is a basic oxide, and you can see the color. What's the color? Please note down the color. Good. So that is magnesium oxide. And this oxide is only very slightly soluble in water. Therefore, we may not easily get the results we want if we dissolve it in water and test with litmus. So, we shall leave this at this point, and I hope you have noted the color. The next element, the next metal we shall look at is calcium. So, I have here calcium, and I'm going to pick a small granule of calcium from inside there. This is calcium. How does it look like? Sorry? What is the color? Good, that is calcium. So we want to burn calcium in presence of air or oxygen. And we see the color. Okay, now let's pick a bigger piece. Let's pick a bigger piece so that we can see it more clearly. So be very observant. What's that color of the flame? I hope you have seen the color of the flame. Okay, good. So that is magnesium, rather calcium, and the product is there. What's the color of the product? Please note down the color of the product. Good. So what is formed there is calcium oxide. And you have seen the color and noted down. Then we have the next metal there, which is copper. Copper exists in many forms. This one is called copper tannins. So, this is copper. And what is its color? Please note the color down. Good, that is copper tannins. So, we want to burn copper tannins. And you see the color of the flame and the color of the product formed. Which flame is that one? What is the color? What's the color of that flame? What's the color of that flame there? Good. So that is how copper burns in here. Let's look at the color of the product. Okay. So that is copper. We are going to put the product there. And lastly, we have zinc. Zinc. Here we have what we call zinc powder. Zinc powder. So that means we cannot use a pair of tongs. So we are going to use a spatula and scoop some zinc powder out there. So that is zinc powder. Look at the color. Good. So we are going to burn this zinc in presence of air. Note the color of the flame and the color of the product. Beautiful. So you have to look critically at the product and note its color. Note the color of the product there. So this product here has a different color when it is hot and a different color when it is cold. That's why I'm leaving it there, so that you can see when it is hot, what is the color, and what is the color when it is cold. So that is, when it is hot, the color is that. Let's leave it to cool, and we see the color. Let's leave it to cool there, and we see the color of the product. Okay, now, as that cools, we say that these oxides, some of them can dissolve in water, while others cannot dissolve in water. But when they dissolve in water, they all form alkaline solutions. Therefore, we are going to try one example which dissolves in water, and that is calcium oxide. So I hope you that there. Let me get some water. I need a little amount because my calcium oxide is also small. So I have my oxide there. I'm going to put it inside. So I shake to dissolve it. So now this is what you form. You can realize that even calcium oxide, when you dissolve it in water, it does not completely dissolve. It slightly just dissolves. Now, we want to test the resultant solution. We want to test the resultant solution with red litmus paper. If it is really alkaline in nature, then it must be able to turn the color of red litmus paper to blue. So we have here red litmus paper. We are going to dip it in this solution. See whether it can turn the color to blue. So we are leaving it there for some time. So, look at this, where we dipped. Look at the two regions, the region where which did not touch the solution, and this part. Can you notice that there is a blue color in this region? Yes, that is good. So that shows that this solution and other metal oxides are alkaline in nature, although some metal oxides are just not soluble in water. Meaning that those ones, when they react with acids, they usually form salts and water. So that has been our demonstration of the reaction between metals and oxygen. Thank you for listening and have a blessed day.